calculate y 0.1, y 0.2 using the first order differential equation 1 plus xy from a third order polynomial with given a point. So this is what it means is about the point x equals to x naught. In this case, x naught is 0. So this is the formula that you want to use. Px, Taylor series polynomial. By x naught plus first derivative x naught multiplied by x minus x naught plus second derivative x naught. X naught is the point that was given to you, about the point x naught. So Taylor series, you're expanding this, you're forming this polynomial about the point x equal to 0. You also can write your derivative instead of a next one is triple prime, which is a third order derivative. Over 3 factorial. Some authors would like to write this as like the first order. You know, some people will write the first order as like this, 1. You know, it's supposed to be a 1 factorial here. It's quite an easy formula to remember because we're not going to going up to infinity. Second order, you also can write this with a small parenthesis 2. Don't just put square, you know, it's a bracket with a 2, it means second derivative. You also can replace this with 3, indicating a third derivative. So now we can see these things are quite matching. First derivative here, and then it's matching with the factorial, 1 factorial. And the power here is also 1. As you can see, second derivative 2, so therefore it's matching 2 factorial, and then it's also 2 squared here. Similarly, third order derivative 3. So that's how you look at it, so that you don't make mistake. So make sure you write the formula correctly first, because in this problem we are going up to third order polynomial. So I must have up to third order polynomial right here, up to the third order polynomial. Then if it says a second order polynomial, then you don't have this. But now it's third order polynomial. Any questions so far?
No, sir.
Okay.
No, sir.
Now we already given that yx naught is y naught. You also can call this y naught. Y subscript naught equals to 1. This is already given to you. So now let's, this also given to you. Y prime x is 1 plus xy. The second derivative of that is x. So this one, you can just put this as yx or y, it doesn't matter. So second derivative, you take the derivative of the first derivative again, you're going to get applying product, the derivative of 1 is 0, then the derivative of x, y, you apply the product rule, x, you guys remember the product rule, u prime v plus uv prime. So you take the derivative of one, multiply by not taking the derivative of the other, plus you take the derivative of the other and multiply by the derivative of the other one. So in that way, if you apply the product rule, if I don't take the derivative of x, and then but I'm taking the derivative of y, it's going to be y prime x. Now I take the derivative of x, which is I'm taking the derivative of x with respect to x. Okay, you're taking the derivative with respect. This is dy dx. That's what it means. Taking the derivative with respect to x. So when you're taking the derivative with respect to x, of course x will become 1. Now this part here is like implicit differentiation. Okay, now first you don't take the derivative, then taking the derivative of this, which is y prime x. You just put y prime x here because y is a function of x. We don't know what that is, but we already know here. Later on, we substitute. Then next, you take the derivative of x with respect to x. That's going to give you 1. And then you don't take the derivative of this. Gives you y as a function of x. So this is going to be x, y prime x plus yx. Next, you can do y triple prime derivative, third order derivative. Again, you apply the product rule on this. I think we have already been through this earlier. I'm going to move on quickly here so that we can cover all the examples. So this has already been done here earlier. All the derivative has been done here. So we can come here. She's already done here, this part. Okay, so I'm going to just write the result here. But you have to know how to do this. There's going to be x, y prime. I can just write this quickly. X, y, double prime x plus y prime x plus y prime x plus 2y prime x. Okay. Any question? At x, now you evaluate them at the point, the given point. So yx naught is y naught okay. Then you just evaluating evaluating y, the first derivative for y, and second derivative and third derivative with the given points. The given point is at x equals to 0, y equals to 1. So just plug and chug. We already evaluated them. Okay, you already have them. So you just are evaluating them at this point. So you have evaluated all the derivatives in the function itself with a given point x equal to 0 and y equals to 1 at that point. Now we're going to substitute them in the Taylor series polynomial. So the polynomial is yx naught plus y prime x naught for 1 factorial y double prime x naught x minus x naught squared divided by 2 factorial so you then you go ahead and substitute them. X y naught is 1 plus y x naught is 1. Sorry, here, right here. Right here. See, this is y. Everything is here. We're going to just substitute whatever value we got here into that formula. x minus 0 plus 1 2 factorial plus 2 3 factorial. Then you do the mathematics, just evaluate them. So px is going to be 1 plus x plus 1 half x squared plus 1 3x squared cube. So that's a Taylor series polynomial. Evaluate at x equals to 0.1 and x equals to 0.2. 0.1 is equals to 1 plus 0.1 plus 1 half 0.1 squared plus 1/3 0.1 cube. 1 plus 0.1 plus 0.05 plus 0.0003. P01. Actually, this is you can just leave this in fractional form. 0.001 divided by 3. You punch them later in the calculator, you will get it will go on, as the more the decimal places, better. If I write this to 6 decimal places, then it's going to be up to here. For this 6 decimal places, it's going to be up to here. In 6 decimal places. P0.2. Hello guys, are you all still connected?
Yes, sir.
Yes,
Yes, sir.
yes, sir.
Six decimal places. So you also can do this way. Probably you just create the, if you're told to find the Taylor series polynomial, and this is the Taylor series, this is the polynomial. This is a polynomial. Once you find the polynomial, then you will be able to evaluate the polynomial at various points. For x equal to 0.1, x equal to 0.2, and so on. These are approximations. But if you do the exact value, if you go this is how you find the exact solution. The exact solution with the exact answers. the exact solution. This is our approximation. So this is approximation. Exact solution. Okay, can you guys calculate this at 0.1 and 0.2, see what you get? -1 plus 2 to the power of e 0.2 is how much? I don't know if this is correct, but you guys can check later on. But you can see apparently the approximated value and the exact value are not same, right? But they are close, not very close. Okay, there can be some error, and you also can see from here that at 0.2, this is giving you 1.222667, but that is giving you 1.44. This also you have to calculate to 6 decimal places, just to make you aware, to show you what is the Taylor series polynomial doing. It's just giving you an approximation. So the higher the order of the derivative, probably you'll get more accurate answer. Right now, we are just going up to the third derivative until the third order polynomial. Therefore, we are not going to get a very accurate answer. If you take it to a higher level derivatives, then you might get a more accurate answer. Any question? Satish Rao present. Satish?
Yes, sir.
Okay. Satish, I'm sorry, Satish, you're having a bad experience with online classes because I saw your message in the Facebook.
No, sir.
He said all the students' marks are declining after the online. Is this just a joke or real?
Joke, sir.
No, if there's anything we can improve, you should tell us how I can improve it. Please tell me if there's anything that I can do. I gave students assignment and you guys are doing all kinds of weird things. What can I do? If you have no idea how to get started, you can contact me. The few students finished earlier. Like I gave them a lab or assignment. I gave them 2 weeks, but they finished in 2 days. And then send it to me and ask me to look at it if they're doing it right. So you also can do that. But you cannot send me at the last minute, at the end of the 2 weeks. If you can do it quickly within 1 or 2 days, then I can give you feedback. You ask some students who are getting full score, that's how they got it. Especially the last assignment in Mathematics 2B and also the signal and systems. Quite a number of them have finished it in 1 or 2 days. So Satish, if you have any problem, you can always call me, okay?
Okay, sir.
Don't take it to Facebook, the management see, they will be not happy. I don't mind, but I'm asking you, I know you guys just playing in the social media, but that can get you into trouble. But it's nothing serious. You have your right to express your opinion, right?
Yes, sir.
But if anybody have any problems, please contact me. Okay, let's do the next one. So this is the problem. Given yx, last time I gave you guys this, asked you to practice. I'm sure none of you practice this, but I'm going to do this now. Given that yx is a solution to this differential equation, and the initial point is a differential equation, and this is the initial point, find the value y 0.2 from the second order. So this is the one thing that you want to know. Second order, we are only interested up to second order Taylor, only second order. Second order. Then we also, please note about our expansion is going to be about x equal to 0. X equal to x naught is 0. And then the y naught is y0, which is 3 in this case. So having figured that out, let us go and write the Taylor series polynomial first. Px y x naught plus y prime x naught, x minus x naught plus 1 factorial plus y double prime x naught x minus x naught squared divided by second factorial. So I'm going to go only up to the second derivative, because here we already told to evaluate, to find the polynomial only using the second order Taylor polynomial. So we only have to go up to second order. This is second order. Y double prime. This is second order. Second order is referring to the order of the derivative. In this case, the derivative is, Okay, next thing, all we have to do, we already given the first derivative. I'm going to use y1 prime x is given as function of. So this is the one that's given right here. A function of y is a function of x. You don't have to put the function of x if you don't want to put, but I'm going to put here so that later on substitution becomes easier. Plus 2. Y double prime. Y double prime x is taking the second derivative. The derivative of this with respect to x is 0. Derivative of 2 with respect to x is 0 because it's a constant. The derivative of this, this is how you do it. Just like the ordinary, let's say we are given, for example, if we are given x plus 2 squared, how do you take the derivative of this? D by dx is equals to 2. I will write this in a different color. Example, the given y is equals to 3x plus x squared 5 or something. If I ask you to find the dy dx, which is y prime in this case. So what do? You bring the 5 here, and then you repeat what's inside here. And then that's how you do it. And then what do? You multiply by the derivative inside here. After doing this, you're going to multiply by the derivative inside here, which is just 3 plus 2x. Okay. Similarly, this is y cube x is same as y x to the power of 3. Okay. So when you take the derivative, you do the same, apply the same principle that we just illustrated. You bring the 3 down, and then yx two. Okay. Then you multiply by the derivative inside here. Multiply by the derivative of this. The derivative of this is dyx dy dx. Okay. So I'm just elaborating. Some of you are having a problem with these things. So I'll just show you this for once. So this is going to be, you can write this as, and then y prime x. Okay, any question? Any question on the derivative? Review and the derivative? Any question? All understood? Okay. Are you guys still online?
Yes, sir.
Okay. So after you're done with this, then you go ahead and evaluate at the given point about evaluate about x equals to x naught, which is 0. And then y x naught is simply y naught. In this case, it happens to be 3. So you evaluate at this point. Therefore, y 0, this is a y naught. Okay, or you can write y naught equal to y0 or whichever. So that's going to is 3. And then first derivative y prime 0 is 3 cube plus 2. So substitute inside the first derivative. You cannot see this. Then you can write like this. Y prime is y 0 cube plus 2. First derivative. Sorry, not 0. Sorry. Y cube 0 plus 2. which is equivalent to writing y cube y naught plus 2. Okay, what is y naught? Y naught is 3. So 3 a cube plus 2 is 29. Any question, please look at it. Y double prime 0. Again, you go back to the equation that you derived earlier, and then you can write this as 3y not x. Okay, and then y prime, sorry, not x, 0, 0. So these are the equation I'm using, you know, this is the equation I'm evaluating. This equation, which is 3. What was y naught? Y naught is 3. Sorry, there's no 0 here. Okay. So let me 3 y naught squared prime. 3 y naught squared. Y naught is 3. Y naught prime 0 is 29. How much is that? $783. Any objection? Okay. I just pause for a few minutes to ask you guys to take a look at this and see if you have any problem. Okay, let's move on. So after you find this, the next thing is I just plug everything into the polynomial. This is the equation that you're going to substitute in. So Px is Yx naught is Y naught. One factorial plus y double prime 0 x minus x naught squared 2 factorial is 2 times 1 and then this is y naught plus y prime naught, then x Okay, it's not a function of x, it's just x. Multiply by x plus, you don't have to write so many steps, if you know what you're doing. I'm just writing them in detail so you will be able to follow. Divide by 2. Y naught is what? Three. Y naught prime, we calculated earlier, right here. Y naught prime is 29. So this is same as y naught prime, same. So y naught double prime. They are the same. Three plus y naught prime is 29. X plus y naught double prime is 783. 783 divided by 2. Okay, this is the polynomial. Once you have this polynomial, then you're good to go. So now we can evaluate. Once you have this formula, the equation was given, the initial, this is called this point about which you're going to develop your Taylor series polynomial. After you develop the polynomial, then you evaluate the polynomial at when x is 0.2. Again, when they mention around x equal to 0, that means this is your x naught. Also given here, the value when x equal to 0 is 3 is given here. Given a differential equation and 1 point, you can develop the polynomial. Then let's evaluate at p equal to 0.2. 3 plus 29, 0.2 plus 783 over 2, 0.2 squared. P 0.2. So if you plug and chug, this will give you 5.8. This will give you 15.66. If you add them up, $24.46. Okay, any question? Are you guys still following?
Yes, sir.
Yeah.
Are everybody
sir.
watching movie? Polynomial of degree 4. for fx is x to the power of -2 about the point x naught equals to 1. Okay, first thing you do, you write down what's given here. Here they didn't give you the derivative. Unlike the previous problem, they give you the differential equation, isn't it? The previous problem, they gave you the differential equation. Do you guys note this? In the previous problem, they gave you the differential equation. This problem, differential equation is not given, but the function itself is given. From the function, you can write your differential equation. Please note that you are going to have a degree 4 polynomial. What it means is you have to go up to y fourth derivative. Or you can also write like this, fourth derivative. So you take the derivative 4 times. Okay, go ahead and take the derivative, all of you. Just don't sit here and watch, because you can just see if I'm making mistakes. You take a piece of paper and pencil, you also try to do, then you don't feel that bored. Then derivative, first derivative, what do? You bring the -2 here, x to the -3. Second derivative, then you bring the -3 over, bring the -3 over here. -3 times -2 is 6. Then you subtract -1 from here. You subtract -1 from here, and you get -4. Then third derivative, same thing, -24, x to the -5, fifth derivative, sorry, fourth derivative. So if you don't want to write the prime, you also can write this as 3. The next one is 120 x to the power of 6. Next, you can evaluate all these things. You can evaluate all these things about 0. Sorry, about x0. And note again, your x0 is not 0 here. It's a non-zero value. X is not a 0 anymore. It's a non-zero value, okay? In this case, they give you 1. The previous 2 problems, you had x not equal to 0. So you plug in, evaluate one by one, x naught then you evaluate the first derivative at x naught, which is 1, then give you -2. So you continue to do this at all the derivatives. For doing that, just plug into this polynomial And then, of course, this polynomial is going to be long because you're going to up to the fourth derivative. Over 2 factorial, 1 factorial, and then third derivative, before factorial. So we already calculated them. So this is going to be 1 minus 2x minus 1 plus 6x minus 1 squared divide by 2 factorial, which is 2 minus 24 x minus 1 cube divide by 3 factorial, which is going to be 3 times 2 times 1, which is going to be 6 plus 1 to 0 x minus 1 to the power 4. 4 factorial is 4 times 3 times 2 times 1. 4 times 3, 12. 12 times 2, 24. If you simplify them, you get 3x 1 minus 2 x minus 1 plus 3 x minus 1 squared plus minus 4 x plus 1 cube plus 120 divided by 24 is 5 x minus 1 to the power of 4. So that's a polynomial. With this polynomial, you can do wonders. Now you can use it to find 0.9. Find the value of this polynomial at p when x is 0.9. Use it to approximate use the polynomial Okay, now P 0.9. Let's do P 0.9 first. So how much is that going to be? P 0.9. One minus 2 minus 0.1 plus 3 minus 0.1 squared minus 4 minus 0.1 minus 0.1 cube plus 5 minus 0.1 to the power of 4. So P 0.9 is how much? Anybody got solution?
3.6345, sir.
3.6345. 3.6345.
Yeah.
Okay. And then for P 1.1 is going to be 1 minus 2, 1.1 minus 1 plus 3, 1.1 minus 1 minus 4, 1.1 minus 1 cube plus 5, 1.1 minus 1 to the power of 4. So this is going to be just 1 minus 2, 0.1 plus 3, 0.1 squared minus 4, 0.1 cube plus 5, 0.1 fourth. This one, so P 1.1, I think I got the answer from somewhere. I don't know whether this is right or not. Please check. Did you guys find the answer? Did you guys find the answer? This is Are you sure, G? Can you please, JJ? Can you please
Yes, sir.
check again?
Yeah, correct,
The
sir.
answer, huh?
Correct.
Correct.
Yeah, sir.
Try again and see, because the answer is telling different here. I just have the answer only. I don't know about the math. No, this is answer that's giving a year as 1.2345. Okay, anyway, you guys go home and check. There can be error in the answer, okay?
Sir, for the answer, 0.91 is correct, 1.2345.
Okay, thank you. Okay, I'm going to start giving you guys some problems as assignment, but I don't know when the deadline is, but I'll give you one problem at a time so that you can start doing it. Find the Taylor polynomial. Find the Taylor polynomial find px. I put Taylor polynomial find the Taylor polynomial of degree about the point x, point x equals to 2. For the following functions. And verify in MATLAB. For now. So when I do some other tutorial the next time, then I'll give you another problem. So this is part of the assignment 2. So you start doing now, assignment 2. Assignment 2. Start doing now. So this is part of it. This is part of it. Maybe you can call this number 1. And then number 2 come in. We got number 3. and then got number 4, and then got number 5. So you start finishing it now. Approximately this will be due. When is your last day of class? Okay, please don't get help from friends, especially from friends who don't know what he's doing himself. So maybe make it due around 29 June, Kenna. Maybe, huh? Hello? Hello? Are you guys still there?
Yes, sir.
Yes, sir.
So 29 June, do we still have class? What date again?
29
June.
is Monday, 14th week, Monday, sir.
So everything must be due before 29 June. So the sooner you hand in, better. Bye. Okay.